So the very first question comes when you're working with linear algebra is what is the linear part of the name linear algebra? Basically, it relates to the equation. I mean, if you have an equation, for example, x plus 2y is equal to 5, is this equation a linear equation or not? So, is this a linear equation or not? So I will show you a few of the examples, but beforehand I would need you to remember a few points so you can basically differentiate between a linear equation and a non-linear one. So how would you differentiate between a linear equation and a non-linear equation? I would share with you 5 points which are written behind me on the whiteboard, which will help you identify whether the equation given to you is a linear equation or it is not. So the very first point is the polynomials with degree 1. Basically, if you have an equation, if you have basically any sort of equation with unknowns that have degree greater than 1, for example x square plus x plus 5 is equal to 0, which is written also here like this one, this would make it like the part which make it a non-linear, that part would be the degree 2, since no unknown should have a degree greater than 1, whether be it in the form like x square or in later courses, like for example in differential equations we have the derivatives. If any of the variable has a degree greater than 1, that renders it non-linear. And the same example here as well, like y cube minus 4y plus 6 is equal to 0. So the y cube part makes this equation a non-linear equation. The very second point is the product of variables. Now, it's a very interesting case, since we have both the unknowns, both the variables x and y, and they also have a degree 1. Now, there's one different thing happening here, and that's they are product x multiplied by y variable. No two variables should multiply with themselves or with the other variable. So x multiplied by y, both are unknown, both are variables. This makes this equation a non-linear. I would also write it right in front of it like it's a non-linear. Non-linear. Same with this one. Non-linear. And I would also underline or highlight or circle around it so you would know what makes this equation a non-linear equation. Now coming towards the second example, as you can see now, it not just only have the product of two variables, the x and y both have a degree 2. So not just the multiplication part but also the degree part makes it a non-linear equation. Non-linear. So coming towards the third point, which can make which basically makes an equation, non-linear equation that is having a trigonometric function. For example, if you have a variable or unknown x, and that x is in the form of a trig function sine. So any sort of like trig function, sine, cos, tan, cosec, any sort of trig function would render the equation non-linear. Currently here, the very first example of third point is sine x. Sine x, since it's a trig function, it is a non-linear. Same with the second example, the y variable, not just it has the degree 2, but also the equation also contains a trig function cos y, which makes this equation non-linear. So coming towards the fourth point, we have the exponential and logarithmic function. Any sort of log function, natural log, or the normal log, or the exponential will render the equation non-linear. So the very first example we have here has exponential. So not just the exponential, but also the degree of x is square, which means the degree is greater than 1. Since it has the exponential as well as the degree 2, either if an equation has either of the either the logarithmic, exponential function, or the degree, or any of the other, like if an equation satisfies any of the point, the equation would be non-linear. So it's a non-linear. Coming towards the second equation, example, that is ln of x, which is natural log of x plus x cube. Now the variable or the unknown x has a degree greater than 1, which is currently here in 3, and also it contains ln of x, which renders it non-linear equation. So coming towards the last point, non-polynomial roots. What does it actually mean? Basically, if you have a variable currently we have x here. So if we have x, but it's under root, so under square root, so the power of x is, if I write it down again in a different manner, it's 1 by 2, which is less than 1, which also renders it non-linear. So the power should not be greater than 1 and should not be less than 1. So that would make the equation non-linear. And the last example, x multiplied by y whole under root. So basically, not just they are multiplying two variables, but they also are under the square root, so which makes it non-linear again. So for linear equations, I would just give you 3 of the examples which I have written down. Now, if you try to check whether these equations are linear or not, the very first example, x plus 3y is equal to 7. Now we have two variables, x and y. Do they have degree greater than 1 or 1? Currently they have 1 degree and they're also not multiplying with themselves. So and there is no exponential, no trigonometric function as well, no polynomial, so they are linear. Coming towards the second example, y is equal to 1 over half x plus 3z plus 1. Now currently this part, it's a coefficient, so it shouldn't bother us since the variable x has a degree 1 and all the other variables, for example y here and z here, also have the degree 1, which makes it linear. Coming towards the last example, x1 minus 2x2 2x3 plus x4 is equal to 7. You can see here they are given a number x1, x2, x3 and x4. For example, if we when we are working with different data, different characters, basically on the horizontal axis, when we have a matrix, those are known as the characters or the features of the data. So if we have, for example, 100,000 sort of features, and we also work with these sort of matrices when we are working in machine learning and other stuff. So if we have, for example, 1000 columns, but we don't have 1000 alphabets, there are only like 26, 27 alphabets, right? So how would we be able to give them different variables? So we just give them, like for example, x, and we just give it a subscript x1, x2, all the way up to xn. So this is much more doable than to use alphabets, since alphabets are limited, and giving a subscript to a single alphabet, it's much more easier and can be done on a lot of data sets. So here the third equation is also linear, since it doesn't violate any sort of any other point which we had discussed earlier, any of the 5 points. So it is also a linear equation. Now if I give you a few more examples here, for example, example 4, which is x plus 3 under root y is equal to 5 and 6. 3x plus 2y minus z plus xz is equal to 4 and y equal to sine x. What do you think? Are these linear or non-linear equation? Let's see. The number 4th equation, it's x plus 3 multiplied by under root y, square root y. Since the variable is under the square root or in the square root, if I say, this makes the equation non-linear. So it's a non-linear equation. Non-linear. Coming towards the 5th example, is this linear? Let's see. 3x, okay, plus 2y minus z, okay. xz, x multiplied by z, both are variables, both are unknown, they cannot multiply, and if they do so, they would make the equation non-linear. So it's a non-linear equation. Non-linear. Coming towards the last example, that is y is equal to sine x. Both y and sine are unknowns or variables, and since no variable should have the trig function, this makes this equation non-linear equation. Okay, so basically this was the way we find whether the equation given to us is linear or not. That is the main part. And linear equations, they form a line. If we talk about xy plane, in xy plane, this equation would be forming a line, and that is really important to understand why linear equations are needed. So, and if they are not, they won't be required, and they are not being used in the matrices, and especially in linear algebra, which is the essential part, which would be using all of the linear equation, the systems of linear equation, and afterwards we would be making matrices, upper triangles, and so on and so forth, a lot of stuff. So just remember this part, what makes the equation non-linear, and what points, if they are not present, makes the equation linear. So that's it. Thank you very much.